So we are going to be starting our trigonometry section. So the first thing we need to talk about is right triangle trig. So we're going to do a review today on right triangle trigonometry. So right triangle trigonometry obviously has to deal with a right triangle. Given a right triangle with acute angle theta, if it's a triangle, then if it's not the right angle, then obviously these two are all going to be acute. You have to put your angle in somewhere. So anytime you're trying to set up these ratios, it's going to be with respect to the angle you're talking about. So you have to know where that angle is located. So I'm going to go ahead and put theta down here. Okay, so now I can look at how to label the sides of my triangle. So across from your right angle, this is always going to be my hypotenuse. And then if I am looking at my angle theta and I have to travel across the triangle to get to the other side, that means this is going to be the opposite side because it's opposite of my angle theta. And then this side here is going to be my adjacent side. Okay, these trig functions here, you may be familiar with the first three, maybe not these three. This is sine, cosine, tangent, cosecant, secant, and cotangent. These three are just reciprocals of these three. So if you know what sine is, all you have to do is take the reciprocal of it and you'll be able to find cosecant. Okay, so defining our trig functions, sine is the opposite side over the hypotenuse. Cosine is the adjacent over the hypotenuse. And then tangent is opposite over adjacent. Okay, and then these ones are just the reciprocals. Cosecant is the reciprocal of sine. So once I know sine, I just flip it over. Hypotenuse over adjacent. Secant is I apologize, that's not right. Hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is going to be adjacent over opposite. Here's an example. So what I like to do when I'm doing these is I like to label my sides. So they're asking us to find all 6 of these trig ratios. So I definitely need the measurement of all 3 sides. As you can see here, I only have the measurement of 2 sides. So it's a right triangle. You just quickly do your Pythagorean theorem to find out what the measure of the third side is. So if I do my a squared plus b squared equals c squared, remember c is your hypotenuse, and then a and b are just the other 2 legs. So I can go 5 squared plus b squared equals 13 squared. So that'll give me 25 plus b squared equals 169. Subtracting 25 from both sides, I'll get b squared equals 144. So b equals 12. Normally, when we take the square root, we always have that plus or minus as our answer. This is a triangle. Obviously, we're not going to have a negative measurement for one of the legs. Okay, so this here is 12. I'm going to go in and label my triangle. With respect to theta, this 12 is my opposite side. The 13 is across from my right angle, so this is my hypotenuse. And then this one is right beside my theta, so this is my adjacent. So once you have those all labeled, then you just fill in your trig ratios. So sine of theta is defined as opposite over hypotenuse. So 12 is my opposite over 13. Cosine is adjacent over hypotenuse, so 5 over 13. Tangent is opposite over adjacent, so it's going to be 12 over 5. And then to find cosecant, secant, and cotangent, all you do is take these guys and take the reciprocal. So 13 over 12 for cosecant. Secant is 13 over 5, and cotangent is 5 over 12. And that's it. So one thing you need to remember is that these numbers all worked out very nicely, but you have to remember that anytime that you're dealing with right triangles and you go to do your Pythagorean theorem, sometimes one of your legs may end up being a square root or a radical that cannot be simplified. We don't want to put our answers in decimals. So if you get something that's just, 2 over the square root of 3, once you do your trig ratio, you have to remember that this is not a good form of an answer. You want to make sure that you rationalize your denominators. So you're going to just take and multiply the top and bottom by whatever the radical is in the denominator. So this would turn into 2 square roots of 3 over the number 3. This is a good answer. These two things have the same value. This is not proper form. This one is. Okay, email me with any questions. Have a good day.